Hi everyone. This week we are gonna be focusing on quadratic functions and models, that is, things that can be modeled using a quadratic function as opposed to linear, which we have seen before. Now, we're going to start off with some things that you have already seen in a previous class. So we will review that. Now, quadratic functions as shapes, they look like parabolas, and the two very basic cases are y equals x squared and y equals negative x squared. So what do these look like? Y equals x squared looks like that, and y equals negative x squared looks like that. So the difference being that this is upward facing and this over here is downward facing. Okay, and one of the key characteristics of the parabola is this point, which is known as the vertex, which is the same for both of these, because essentially the only difference is the presence and absence of this negative sign. Now recall, as transformations these make sense, because what does it mean to multiply a function by -1? In terms of transformation, it means to reflect it on the x-axis, to make all the outputs that were positive negative and that were negative positive. So that's the basic shape of the parabola, and thus of the very simple quadratic, which is x squared. Now let's try to see how we can get more complicated quadratics from this. Now for example, I can start with x squared, right? And based on our knowledge of transformations, I can move it to the right, or I can move it to the left. So if I do that, an equation, say the blue one is x squared, if I move it to the right, that becomes x minus a squared, and if I move it a units to the left, that becomes x plus a squared. Now I can also move it up and I can move it down. Right? Moving it up and down would mean making it something like x squared plus c and x squared minus c. Right? Recall that horizontal movement is achieved by replacing x by x plus minus c, and vertical shift is achieved by replacing y by y plus minus c. Which means that if I do both, then my equation maybe looks something like this, which if I FOIL out, that's going to be x squared plus 2ax plus a squared plus c. Which means basically it looks like x squared plus something times x plus some things. Right? And this is almost a general quadratic. The only thing missing here is scaling. Now if scaling is involved, right, which means I'm going to multiply the x squared by something and then something times x and then the constant. This brings us to what we call the general quadratic equation. Whenever you hear the word general equation, it means that it's a kind of equation which can be used to represent all possibilities. Right? So what we've done here, we started with the most simple parabola, and we said that any other parabola is just going to be left, right, up, down shift, and either stretched or shrunk. So including scaling and the movements get us to the general quadratic equation. So this general quadratic equation is written as ax squared plus bx plus c, and we say a not equal to 0 because if a equal to 0, then it is linear, right? So it becomes a line. So for obvious reasons, we don't want a to be 0. And this is the general quadratic equation. Okay. Now this quadratic, what is it going to look like? At some point, it's going to look like a parabola, and it will have this vertex, which will be our goal to find out, right? It can also have a y-intercept, and it may or may not have x-intercept. Okay, that depends on the particular quadratic that you are working with. Now, that is the general quadratic equation. As it stands, it doesn't give us a lot of information. So what we do is we instead write these quadratics or parabolas in the standard form of quadratic. Okay, so as a standard form of quadratic, we rewrite this as a times x minus h squared plus k. Okay, which if you go back here, that's just this along with the scaling. Okay. All right. Now, if you have a problem which says express this in the standard form, then the tool here is going to be completion of square. To use completion of square, you have to recall that a plus b whole squared is a squared plus 2ab plus b squared, and a minus b squared is a squared minus 2ab plus b squared. Okay, so let's try and express this in standard form. So first of all, what I'm going to do is I'm going to take care of this 2, right? So this is going to be 2x squared minus 6x plus 13. Now, based on what this looks like, right, I make a guess that I want it to be x minus 3 squared. Well, it's not a guess, but basically you take the number 6 and you half it, negative 6, and you half it. So if I want that, this should be x squared minus 6x plus 9. So I'm missing this 9. Since I'm missing the 9, I'm going to add and subtract the 9. So I'm going to write this as x squared minus 6x plus 9 minus 9 plus 13. So 2x squared minus 6x plus 9 minus 2 times negative 9 is 18 plus 13. And this, the reason I did all of this was to write this as a square. So this is x minus 3 squared, negative 18 plus 13 is minus 5. And this is going to be the standard form. Now, completion of square is something that you must have seen in 103, and it also follows from basically applying this particular property and writing it as a square. Now, the last thing in this video is, well, actually, I'm going to stop at this standard form, and then we are going to discuss in the next video the consequence of expressing this in the standard form. Actually gives us a lot more information than expressing it in the general form. Okay, that's it for this video. Thank you, everyone.